We've looked at balancing equations and mole ratios and trying to figure out how much of each substance we need and are going to get in a reaction. But when we actually carry out reactions, we usually use one reactant in excess, and that means we're going to have too much of one thing. And when that happens, it's not a big deal. It just means that that one will not get all used up. So whatever we have excess of, whatever there's too much of, will not all get used up in the reaction. Whatever there's not enough of limits the reaction. It means the reaction is going to end when we're out of this one. So we have a limiting reactant that is entirely used up in a reaction, and then we have the excess reactant, which we have leftovers of. And that's so that we can ensure that we get all of our one thing reacted. Now, what we're going to do in this lesson is try to figure out how to identify what the limiting reactant is. We're going to look at a couple different methods for that. So the first one is just pretty straightforward. We use a balanced chemical equation and we look at the mole ratios of the reactant. So if I'm supposed to have like a 3 of A plus 2 of B produces junk, then I know that I need a 3:2 ratio of those two things. And if I don't have that, if I only have like a 2:2 ratio, then I know I'd be limited by A. The other thing we can do is we can look to see which of these substances would produce the most product. So if we're getting AB, then if this produces more with the 2 moles of B than 3 moles of A does, then we know that our 3 moles of A would limit. So we're going to look at a couple of those examples so I can show you what I mean. So the first thing to do is always start with a balanced chemical equation. That tells us our mole ratios. That's what we need. So silicon nitride is produced by reacting 2 grams of solid silicon with 1.5 grams of nitrogen gas. So those are not moles. Those are masses. So first we have to, and this is determine the limiting reactant. So it's telling us how much stuff we're mixing together, but it's not telling us how many moles we have. And so we need our balanced chemical equation so that we can figure out what's going on. So 2 grams of solid silicon, so Si, solid, reacts with nitrogen. Now remember, nitrogen is a diatomic molecule, so N2 to produce Si3N4. We need to balance this equation. Looks like we need 2 of these and we need 3 of these. So we can see our mole ratio of silicon to nitrogen is 3:2, and we get a 3:1 ratio of silicon to silicon nitride and a 2:1 ratio of nitrogen to silicon nitride in our balanced chemical equation. So we're going to use this, and I'm going to go through each of those 2 methods to figure out which one is our limiting reactant. So compare the mole ratios of the reactants. So here's our balanced equation, 3, 2, 1. And so we were told that we had 2 grams of silicon, and we only had 1.5 grams of nitrogen. So what we're going to do is get our molar masses to get our moles. So silicon has a molar mass of 28.09. Right, we can find that on the periodic table. And nitrogen has a molar mass of 14, but this isn't nitrogen, it's N2. So this has got a molar mass of 14 grams per mole. This has got a molar mass of 28.09 grams per mole. And so what we do is we look at this and we're like, all right, so 2 grams of silicon is how many moles? So 2 grams times 1 mole per 28.09 grams equals, our grams cancel, and we get our mole of silicon to be 0.0712. Same thing over here with nitrogen. We get our 1.5 grams of nitrogen times 1 mole per 14 grams, and we get our moles to be 0.0535. Moles N2, this is moles Si. Right? Now, we know the ratio we want is 3 silicon to 2 nitrogen, which is the same thing as 1.5 silicon to 1 nitrogen. Now let's see what we actually have. We actually have 0.0712, so right, this is want, this is have. We have 0.0712 silicon to 0.0535. And I'm just going to go ahead and type that into my calculator and see what we get. So 0.0712 divided by 0.0535 is 1.33. So this equals 1.33 to 1 of Si to N2. Well, so I have my 1 mole of N2 that I need, but I don't have the 1.5, I only have 1.33 of SI. So this tells me SI is limiting. Okay, there's not enough of it. I should have 1.5 to 1. I only have 1.33 to 1. So method 1, we just can pull the mole ratios of the reactants of what we're given to what we actually wanted. Method 2, we're going to do this the other way. We're going to see, okay, well, how much product would each one produce? So again, we have 2 grams SI, and we have 1.5 grams N2. Remember, this was 0.0712 moles, and this was 0.0535 moles. Now, what we know is we get a 3-to-1 ratio of silicon to Si3N4 in terms of a mole ratio, and we get a 2-to-1 ratio of nitrogen to Si3N4 in terms of a mole ratio. I don't know that there's an equality there. So if we're actually trying to figure out how much of Si3N4 we're going to get with each one of these, what we're going to do is we're going to say, okay, well, let's say we start with 0.0712 moles of Si. And we want to get that to Si3N4. So we take our conversion factor, our mole ratio, right? And I want silicon to cancel, so I have 1 Si3N4 over 3 Si, right? So I just use the reciprocal of this, so I would get my SIs to go away, and I get 0.0712 over 3, which is 0.0237. 0.0237 moles of the silicon nitride. Okay? So using the 2 grams of tin that I'm given, or silicon that I'm given, I would get 0.0237 moles Si3N4. Now if we do that same thing with nitrogen, so we have 0.0535 moles nitrogen, and I multiply by this mole ratio, I get times 1 Si3N4 per 2 N2, and so I take my 0.0535 and divide it by 2, and I get 0.02675. 0.02675. So what's that saying is silicon can only produce this much, whereas nitrogen that I'm given can produce this much. Well, I can only produce as much as the least amount, and so my limiting reactant is again silicon.